Everyone, this is Phantom Phoenix. Our innovative project for the Smart India Hackathon 2024 was under the disaster management team. Our project mainly focuses on developing an early warning system for Glacial Lake OutBurst floods, commonly known as GLOFS. It poses significant threat in mountainous regions and a lake like Imja Lake, where rising temperatures and glacial meltings create an unstable lakes. Sudden outbursts can lead to catastrophic destructions, causing a lot of life losses in downstream and environmental damages. Timely prediction and real-time monitoring system can reduce such disaster. Here, we are using various technologies that include both hardware and software. The software frameworks and tools involved in this project are QGIS, Quantum Geographic Information System, which collects satellite data. Arduino UNO helps in water level monitoring system. PostgreSQL, powerful open source relational database. Anaconda Navigator develops and runs ML algorithm. Unlike software and framework tools, hardware tools involved in this project are SR04M2. It is a waterproof ultrasonic sensor. David V1 ESP32. It is a microcontroller that has built-in Wi-Fi and Bluetooth capabilities. AC to DC converter. It is required to power the components like ESP32 sensors. Zero PCB. It is generic printed circuit board used for prototyping circuits. The two most important hardware that used here was cost effective. The SR04M2, which was available in most of the markets. It basically works by measuring the distance between the sensor and water surface by emitting the sound waves at high frequency. In our case, we can consider glacial lakes, where the water level is measured by subtracting the distance from the total depth and measuring the time it takes for the echo to return. And David V1 ESP32. It is a microcontroller. It is known for its powerful processing capabilities and integrating wireless communication features. Yeah, now it's time to reveal our idea. We think of integrating all these technologies for creating a best and optimal solution, and it provides the warning earlier before the flood arrives due to glacial lake outburst. One of the crucial steps is data collection. Here, data collection is happens via the two softwares, Quantum GIS and SR04M2, where Quantum GIS is an open source. It helps in data collection. Here, we are collecting the various satellite images through Sentinels or IRSG2, which is the Earth observation satellites. These satellite images can be accessed by QGS via the help of Sentinel Hub plugin. So these collected data can be stored into DB Manager, which this DB Manager is already present in QGIS. After collecting these all data need to be stored inside the database like PostgreSQL. Here we are using PostgreSQL because it helps in collecting various geospatial data. It contains PostGIS extension which helps in collecting such geospatial data. Before storing all of these data, we need to pre-process the data. Such pre-processing can be happened through GDAL, Geospatial Data Abstraction Library, which helps in data preprocessing. It is a robust library. Here, these raster data that collected from satellites are being in different forms like GeoTIFF or NetCDF. These can be abstracted. This can be abstracted with help of GDAL, and it can be made into readable and writable format. Now we get a required data set for our project. Another way of data collection is through SR4M2, which is an waterproof ultrasonic sensor. Here, this ultrasonic sensor collects all the water level details with the help of ESP32 microcontroller, which helps in water level monitoring wirelessly. And collected data will be stored into the cloud platform like Blink. Later, these data can be accessed from Blink. And after all this process, one of the most crucial process is storing the data. Yeah, here we are using two tools which are Blink Cloud and PostgreSQL. After storing all these data, we need to combine all these data sets into one data set. Like there are various data we collected are water level historic data set, temperature, precipitation, longitude, latitude. Now these data are formed and we can use these data for our next process. Now collected data sets are divided into two data sets. One is trained data set and another one is test data. Which trained data is 20% and we can take test data as 80%. These trained data used to train the random forest algorithm. Here we are using random forest algorithm because it gives an accurate out. Here we are doing the prediction based on threshold. And after this, all this, now our machine learning model is ready for predicting the threshold. When there is more threshold value, it will be provide an alert system or a alarm system in mobile phone and send the SMS through mail and message for people living in downstream. This is a real-time monitoring system for an early warning glacial lake outburst floods. And thank you.